And now let's implement this new step, feature scaling. But just before, since we're going to apply a lot of transformations on both x and y, well, we're going to do some print to see the before and after the transformation. All right, so let's create two new code cells here. Let's first do a print of the matrix of features x, then a print of the dependent variable vector y. Now we're going to run the cell to print x, and x contains, of course, in a 2D array, as you can see with a double pair of square brackets, all the position levels going from 1 to 10, so that was totally expected. Then let's print y, which will this time contain in a one-dimensional vector all the salaries corresponding to these position levels, so all good there. But now we will have to do a first transformation, and I'm not even talking about feature scaling. That first transformation will be to reshape this y into actually an array, a two-dimensional array where you have the salaries displayed vertically. And so now the question is, why do we want y to have such a format, in the 2D array? Well, that's because, the standard scalar class that will perform standardization, meaning feature scaling, expects one unique format in its input, when you apply the fit transform method, which is a 2D array. If you input here a one-dimensional vector like what we have here, this will return an error, simply because, well, this standard scalar class expects a 2D array as its input. So now we just have to transform this into a 2D array, and you actually know exactly how to do that because we already did it. I'll give you a hint, this was in the multiple linear regression section. And so now, well, of course, I would like you to press pause on this video and try to transform y, or reshape y into this 2D array with the salaries displayed vertically. All right, so we're going to create a new code cell to do this. And so, well, first we want to update y, and therefore, we will start with this, y equals, and then we'll do the necessary transformation to return this new y. And so how do we do this? So the first thing to do is to take y again, from which we're going to call that reshape function, into which we're going to input, well, the new shape that we would like y to have. And remember how we have to enter this new shape? Well, we have to input here two elements. The first one being the number of rows of this new y, this new format of y we want to have, and then the number of columns. So that's easy, since we want to have the salaries displayed vertically, in different rows actually. Well, what we want to have for the number of rows is, of course, len of y, the length of y, meaning the number of elements in y, meaning the number of salaries. Okay, so that's the number of rows, and then the second element here is the number of columns. And of course, we want one column because we want to display the salaries vertically in a 2D array, of course, and therefore here we input 1, as in one column. So we're going to have, actually, since we have 10 salaries, we're going to have 10 rows and one column. Okay, so it was good to do it again. Now you become more familiar with this reshape trick. Okay, and now of course we're going to print this to see and to check that everything's all right, and mostly that we have the right format expected by this standard scale class, which we'll use then to apply feature scaling. So there we go, print y, and let's first execute this to reshape y, and now let's print y to indeed check two things. That first we have a 2D array, we can clearly see that with the double pair of square brackets, and also the salaries displayed vertically, just like this matrix of features, which is also a 2D array, of course. All right, so now everything's perfect. We're ready to apply feature scaling, and so we're going to do that right away, starting by creating a new code cell here. All right, so now how are we going to do this efficiently? We always want to be efficient when we code, so of course we're going to grab our tool in our data preprocessing toolkit. I'm talking, of course, about the feature scaling tool, and we'll have to adapt this a bit because this was applied on the training and test sets, but no worries, we will adapt it very quickly and efficiently. So I'm copying this and I'm pasting that right here. And now, of course, I would like you to please press pause again and try to figure out on your own what we have to modify here to make this feature scaling work for our situation.